delta H left is equal to A right, delta H right. Now I'm just talking about the magnitude here. It's the magnitude, and A right, A left cancel. So that means the height gained, the magnitudes of the height gained here is equal to the magnitude of the height lost there. So if the height went up here 10.92 centimeter, okay, so then the height delta H left plus the magnitude, so the magnitude of the delta H left plus the magnitude of the delta H right must be equal to 10.92. And if they're equal to each other, then that means one of them goes up what's half of that? 5.46, the other one goes down 5.46. So 2 delta H left is 10.92, and then delta H left is equal to 5.46 centimeters. So this one goes up by 5.46, the other one goes down by 5.46. So then you're left with, the final picture looks like this. Remember the original height that they began were 15 centimeters. Right? They were 15 centimeters, so let's assume that they are the same diameter here. So if this is going to go down 5.46, 15 minus 5.46 is going to be what? That's 454. And this is going to be 94549. Okay? So 9.5, so this one, the new height of this is going to be 9.54 centimeters. Then you got the oil here. That looks longer, 12 centimeters. Then this one goes up 5.46. So 15 plus 5.46. 15 plus 5.06 is 20.46. So what does that look like? This is 9.54 plus 12. The total height there is roughly about 21. Okay, 21, and then this is 20.46. So it's a little lower than the oil. It's going to be 20.46 centimeters. Okay, a little bit lower than the oil. So that's the idea. What if they were not the same area? What if this had twice the surface area? Okay. What if that had twice the surface area? You put in oil, 12 centimeter of oil. Well, what would happen? The original answer, the 10.92, would not change. The difference would still be 10.92. But however, this time, okay, this time what would happen is you have the volume displaced here. Here is going to be, we could start with delta V left is equal to delta V right. And again, this is, I'm talking about magnitude. And then here, this is A left, delta H left is equal to A right, delta H right. And then if A right is twice A left, so you have A left, delta H left equals twice A left, delta H right. And then A left cancel, delta H right is half of delta H left, which makes sense because if you put in some oil, this one goes down, but not as much as this one goes up. Okay, so then you have basically it's going to be it's going to look like this. So if the difference of the heights here is 10.92, so then it's going to be delta H left plus delta H right is equal to 10.92. So you could say here delta H right is half of delta H left. And then, what will that be? And then you have here 3/2 delta H left is equal to 10.92. And then, where is the delta H right will become half of that. 3.64. So the new height is going to be the original height was 15, right? So it goes down 15 minus 3.64, and you have here 693 431, right? So 11.36. So the new height here of the water is 11.36, and you have 12 centimeters of water. Okay, and then you have here the height here originally was 15 centimeters. On top of that, 7.28, 22.28. So you have here, this one is 11.36. So it went from 15 to 11. It wasn't affected a lot. And then here went from 15, wherever the 15 was, went from 15 to 22. So what does that look like? Well, what's 11 plus 12? 11.36 plus 12 was 23.36, right? On the left side, you have 15 plus 7.28, 22.28. So if this is the oil, the water should be a little less than the oil, and that water should be 22.28. Okay? But the difference of the water's level and the top of the oil's level should be still the same, right? The difference between this is 1.08 centimeter. What's the difference between the height in if they were the same? The oil difference here is 1.08. The difference there is 1.08, and it makes sense. Okay, so that illustrates one kind of case of two tubes. Next week we'll do a different one with possibly 3 tubes. Then we're going to get into Archimedes' principle and Bernoulli's equations. Okay, bye-bye.